back to our new class. Today we're going to start lesson 4, chapter 4, which is basically talking about trigonometry and trigonometric identities. So today we're just going to do a little bit of an intro lesson about using algebra with trig functions so that we have a solid foundation going into this unit. So the objectives for this unit are to find common denominators and to factor algebraic and trigonometric expressions. So both things that we learn in algebra, but let's see what it looks like when we... Alright, so when we have a fraction plus a fraction, we need to find the common denominator. So if I look at the problem, x over 5 plus y over 6. Most of us can look at this and determine that our common denominator is 30. Although I know many of you can do this in your head, you're going to have to show me your process because that will help you as we work through the trig identities in the next few sections. So here in the first fraction, I have a denominator of 5. I know that 5 times 6 will give me a denominator of 30, but I can't just throw a 6 in the denominator. I need to keep everything equivalent. So I'm going to use a rocky form of 1 and multiply by 6 over 6, which reduces to 1. Over here, in my second fraction, I have a 6. I need a 30, so 6 times 5 will give me 30. And so if I multiply by the wacky form of 1, 5 over 5, that does not change the value of anything in my problem. So here, this becomes 6x plus 5y, and I cannot simplify that down any further. I take two terms that were originally added them together and combine them into a single term. So let's look at what this might look like with sine functions. I have 1 over the sine of x minus the sine of x. And if you want to think about it in a fraction and it helps you psychologically to put it over 1, then so be it. So now I look at this, I have a sine x and I have a 1, so my common denominator is going to be sine x. Since I already have a sine x in my first fraction, I don't really need to do anything. However, I do need a sine x in this denominator, so I'm going to multiply by the wacky form of 1. So now I pull down the 1 from here, and I have 1 minus sine x times sine x is sine squared x. And if we think about really what x represents an angle. So just to help you think about why we're squaring the sine and not the x, if you have the sine of 30 degrees times the sine of 30 degrees, in the end, this is going to be sine squared of 30 degrees. If you take the 30 times the 30, now we have the sine of 900 degrees, which is a totally different problem. So just remember that the variable out here tends to represent an angle measure, and we don't want to square the angle measure, but we want to square the trig function. Alright, let's try another one. So let's say that we have the problem sine theta all over 1 plus cosine theta plus cosine theta over sine theta. So this problem looks a little bit more intense from the beginning. So let me think about what my common denominator will look like. It'll be the first term, 1 plus the cosine of theta, times the second denominator. So now I have to ask myself, what do I need to do in my problem to make this denominator look like this denominator? So I have the 1 plus cosine, so over here, I need to go ahead and multiply this by the sine theta over the sine theta. Here, I have the sine theta, but I'm missing the 1 plus cosine theta. So over here, I'm going to multiply by the 1 plus cosine theta, or 1 plus cosine theta. So now I'm just going to clean up my numerators. If I look here, I have sine theta times sine theta, so I have sine squared theta. On my right, over here, I have a distributive property problem, so I can take the cosine theta and I can distribute it. Cosine theta times 1 is cosine theta, and then cosine theta times cosine theta is cosine squared theta. At this point, we are not going to go any further with this problem. Eventually, I use my identities and clean this up, but at this point, I've done what I was asked to do. I found a common denominator, and I combined my two fractions. Alright, let's talk about factoring. So if you look at the first problem, 5x squared minus 3x minus 14, you guys use a process in Algebra 2 called split the middle term. So I'm going to split the middle term. So 5 times 14 is 70. So now I'm asking myself, okay, what two numbers multiply to give me 70 that might add or subtract to give me negative 3? So I know that 10 times 7 gives me 70, and if one of those numbers is negative, then in the end, a negative 10 plus a 7 will give me a negative 3. So when I split the middle term, you have 5x squared minus 10x plus 7x minus 14. So basically, when you look at these two terms right here, they should combine to give you that term there. And that's what it means by split the middle term. So now we're going to use that factoring process called grouping. So I'm going to make my first group. It's imperative that you do not group this sign right here in with the second group, because that would change the problem from addition to multiplication. So now I'm going to take each group and I'm going to GCF. So here I'm going to take out of 5x out of both of these terms. So if I GCF of 5x, I am left with x minus 2. I look at what my next two terms have in common, 7x and negative 14. They both have a 7. So that means I'm going to GCF out of 7. When I look at what I have here, I have two terms. I have one term here, I have one term here. They both have an x minus 2 in them, so I can GCF out an x minus 2, and those cancel. And that leaves me with 5x plus 7. Alright, so how does this apply to trig? If you have the problem 5 sine squared x minus 3 sine x minus 14, this is really identical to the problem on the left, with the exception of the fact I took out the x squareds and I put its signs in their place. So I'm going to split this middle term the exact same way I did problem A by using the negative 10 and the 7. So I'm going to take this, and this is going to become 5 sine squared x minus 10 sine x plus 7 sine x minus 14. And again, when I look at these two problems or two expressions and I combine them, I get that negative 3x. So again, this process is so familiar because it's almost the same problem. I'm going to group my problems. Here, I'm going to take out a 5 sine x, and here I'm going to take out a 5 sine x. And you've got to remember that when you GCF that, you have to bring it out front. So 5 sine x. When I look at what I'm left with, I am left with a sine x, and here those reduce down to 1, and I'm left with a minus 2. When I look at my second group, they both still have a 7 in common, so I'm going to GCF out that 7. And when I do that, the 7 is reduced to 1, and we deal with the sine x, minus 14 divided by 7 is 2. So now again, I have two terms. I have term 1 and I have term 2. Each of these have a sine x in common. A sine x minus 2 in common. So all of those will go away. I can take the sine x minus 2 out, and that's going to leave me with 5 sine x plus 7. And this should actually look familiar to the previous problem because we basically used similar numbers. Alright, so I want you to hit pause. I want you to try this one on your own, and when you are ready, reconvene and we will check your answer. Alright, welcome back. When we split the middle term, we're going to take 6 times 15, which is going to give me a negative 90. I need a negative 1 sine x, so 10 times 9 will give me 90, because this is a negative sign right here. This is going to need to be my negative term. So when I do this one, I'm going to group this one a little different, 6 sine squared x. I'm going to do plus 9 sine x and put my negative 10 here. When I go to group this, you cannot group this negative sign in here, so you need to change this to a positive, and you need to put your negative sign right here. When I go to GCF, 6 and 9 have a 3 in common. Sine squared and sine have a sine in common, so I'm going to GCF out a 3 sine x. And when I do that, I am left with 2 sine x plus 3. When you have the ability to GCF out a negative, you should GCF out a negative. So 10 and 15 each have a negative 5 in common. So I'm going to GCF out a negative 5, which leaves me with 2 sine x plus 3. Now, each of these terms have a 2 sine x plus 3, so I can take the 2 sine x plus 3 out of the problem, and that's going to leave me with 3 sine x minus 5. All right, today you have a worksheet 4-1, and your objective today is simply to simplify the expressions. Some of them you're going to be factoring, some of them you're going to find common denominators, just to become super familiar with the process, because starting tomorrow, these are going to become parts of a bigger problem. Have a great night, and come to class tomorrow with questions.